today, and also who have joined in online mode for the International Science Workshop on Trishna. This workshop marks a significant milestone in collaboration journey of Trishna mission, an ambitious partnership between the Indian Space Research Organization and France Space Agency, Trishna. Trishna, which stands for Thermal Infrared Imaging Satellite for High Resolution Natural Resource Assessment, which symbolizes the spirit of international cooperation in leveraging the cutting-edge technology for sustainable future. We are deeply honored to have with us today some of the most distinguished minds in space and technology. Let me take this opportunity to invite our esteemed dignitaries on dais. Director SAC, Mr. Nilesh Desai, Professor V.K. Dadwal, Ex-Director NRSC, Mr. Philip Messengrand, Trishna Program Manager CANAS, Mrs. A.M. Naga Lakshmi, Project Director Trishna, Mrs. Rashmi Sharma, Deputy Director IPSA, Mr. S.S. Sarkar, Deputy Director SEDA, Mr. I.M. Bahuguna, Chair of Local Organizing Committee, and Bimal Bhattacharya, Convener for this workshop. Please, sir. Your presence today adds the immense value to this event, and we are grateful for your time and support. So moving ahead, now I request to set the tone for today's event. I invite Mr. Bahuguna, Local Organizing Committee Chair, to deliver welcome address. Please, sir. Welcome address, sir.
I have to be quick because our Director Sir is occupied. He has to leave also. Respected Dr. Vinay Kumar Dadwal, Indira Gandhi Chair Professor at National Institute of Advanced Studies, former Director NRSC, former Scientist of SAC, and former Director of IIRS Dehradun, and today's guest of honor of this inaugural session of this international workshop on high resolution thermal earth observation, Dr. Philip Messengrand, the project manager of Trishna mission from CNES, Shri Nilesh Desai, Director Space Application Center, Shri Soumya Sarkar, Deputy Director of SEDA and Distinguished Scientist of Space Application Center, Dr. Rashmi Sharma, Deputy Director of Earth and Planetary Sciences and Application Area, Dr. Nag Lakshmi, Project Director of Trishna Mission at URO Satellite Center at Bangalore, Dr. Bimal Bhattacharya, who is Group Director of Agriculture, Forestry and Ecological Group, and the force behind this entire workshop and behind, thermal Earth observation program at ISRO. Senior SMC members, Controller SAC, and other SMC members of Space Application Center, distinguished scientists, research scholars, engineers, and other delegates from all over the globe who are participating in this workshop. Namaskar, good morning, and very warm greetings, and welcome to all of you at Space Application Center. Space Application Center is one of the important organ of Indian Space Research Organization located at Ahmedabad. Basically, it's a center for payload development of various kinds. It is not mere customary to welcome you in the beginning. It is our pleasure, it is our privilege, it is our honor to welcome all the delegates who are the authorities in the subject and who are the experts in the subject from all over the globe, and the delegates who have joined this workshop and to exchange their views, etc. And we welcome you all at this, and it is an honor for us to welcome all of you. We hope that you will enjoy the discussions and interactions in this workshop. I'd like to inform you that November to February is a very pleasant time in Ahmedabad. The temperature ranges from 32, 33 degrees maximum, and minimum is around 20 degrees or 18 degrees, like that. So it's a very pleasant time for 4 months in Ahmedabad. But of course, in next 3 days, we hope that you will enjoy the pleasant weather at Ahmedabad. You will also enjoy, I hope, we are sure that you will also enjoy the hospitality of our SAC colleagues. And also, Ahmedabad is a World Heritage City of India. So you will also enjoy the culture and the Indian cuisine and the food in Ahmedabad, traditional Indian style food made for all of you. Above all, you will also like the scientific culture and the temperament of our SAC colleagues who have joined, to welcome all of you and to share, their experience with all of you in this workshop. And again, welcome to all of you, and especially our guest of honor, Dr. Vinay Kumar Dadwal, who is the authority. I'd like to take this opportunity to inform you that India has a program, foremost program in agriculture and ecological remote sensing. Out of all the remote sensing which is going on in India, out of all, agriculture and ecology happens to be the foremost. And the person behind this program in entire India is Dr. Dadwal. So with these words, I'd like to close my welcome remarks and invite you for the next program.
Thank you, sir, for your warm and inspiring welcome note. Your words have set a positive tone for a day, and we look forward to the meaningful discussions ahead. Thank you. To invoke the blessing of wisdom, light, and knowledge, let us now proceed to a traditional lamp lighting ceremony. I invite all the dignitaries on the dais to join for this auspicious moment. Please. While the dignitaries lamp the light, we will be graced by the soulful chanting of Saraswati Vandana by Mr. Partho Ghosh. Partho, please.
सरस्वती महाभद्रा महामाया वरप्रदा श्रीप्रदा पद्मनिलया पद्माक्षी पद्मवक्रका शिवानुजा पुस्तकवृत् ज्ञानमुद्रा रमापरा कामरूपा महाविद्या महापातकनाशिनी महाशाय मालानी च महाभोग महाभुज महाभाग महोत्साह दिव्यांग सुरवंदिता महाकाली महापाश महावार महांकुश ईटा च विमल विश्व विद्युन्माल च वैष्णवी.
Thank you, Partho. As a token of our appreciation and commitment to the sustainability, we now present supplings to our dignitaries. I now request Mr. Arvind Sahai to welcome Mr. Nilesh Desai, Director SAC. Now I request Mrs. Dimple Garg to welcome Professor V.K. Dadwal. I request Satesh Kumar to welcome Mr. Philip Messengren. Now I request Mr. Dalaka to welcome Mrs. Nagalakshmi ma'am. Now I request Mr. Arvind Sahai to welcome Mrs. Rashmi Sharma ma'am. I request Dimple Garg to welcome Mr. S.S. Sarkar. Now I request Satesh Kumar to welcome Mr. Bahugana sir. Sir is a part of this local organizing committee. Now I request Dheeraj Adaleka to welcome Mr. Bimal Bhattacharya sir. Thank you all. Now to proceed further, to give a brief overview of SAC activities, I request Mr. Nilesh Desai, Director SAC, to give the address on.
Good morning, everybody. The dignitaries on the dais, Dr. Dadwal Sahab, our distinguished friends from France, Soumya Sarkar, Nagalakshmi Madam, Rashmi Sharma, Bimal Bhattacharya, Bahugana Sahab, and all the dear participants from France as well as various other institutions, as well as my dear friends, colleagues from SAC and ISRO. At the outset, let me welcome all of you for this very important International Science Workshop on High Resolution Thermal Earth Observation. And sorry for jumping the queue, because I was supposed to address afterwards. I have some engagement by 11 o'clock, so I have to leave. So I generally start all my addresses either with disclaimers or apologies. So today with apology, I'll be leaving after my address. So please pardon me for that, Dadwal Sahab. So let me welcome once again all of you, and it is a very important event in the French-Indo collaborations, especially related to various Earth observation missions. We have a long history of collaborative efforts, starting with long back. We had worked on megatropics, followed by Saral Altica, and now we are on to the Trishna project. I always forget the full form of the Trishna, because when initially we were trying to name this particular mission, because Trishna, if you see, it is only French acronym. So there is no mention of what Indian part in that particular mission. So I suggested that we should add something so that it reflect the contribution which India is going to do with our visible and other infrared sensors which we are going to give as a part of this particular mission. But the importance of this particular mission need not be emphasized more. All of you know that thermal imaging is very critical, and especially when in the world Earth observation scenario, we find that there is a lack of this particular type of observations. And with the LSTM from ESA and SBG from NASA, long away by 2030 time frame only they will all will be available. So in between we need very good observations of Earth in thermal infrared band, and that will be filled by this particular mission. It will really have a lot of utilities for various applications. And today we have a distinguished guest in form of Dr. Dadwal Saab, who had been a mentor of all my application colleagues here. And as pointed out by Dr. Bahuguna, he has been a pioneer in various activities related to remote sensing, especially for agriculture, forestry, and many other domains. So let me welcome sir and thank for being here at a very short notice. And today, of course, it is an important day for us, for we are having this science workshop for next 3-4 days. But today we are celebrating India as a national integration day, remembering the birth date of our former Prime Minister Indira Gandhi. And she was the Iron Lady of India. All of you may be aware of that. And incidentally, today we also celebrate International Men's Day. So it is ironical that her lady's birthday we are celebrating as an International Men's Day. But it was told that she is a man among all the people in her cabinet. But anyway, remembering her because she promoted a lot of activities related to science and technology. And of course, the current government is giving a lot of emphasis, which culminated into our efforts related to soft landing on Chandrayaan-3 South Pole. So that was really a massive effort on the part of ISRO. And of course, we are basking in the glory of that particular mission. But more importantly, the activities which we do for planetary exploration is only 20-25% part of the work which ISRO does. The rest of the thing is what we are here today to discuss, that is Earth observation, communication, navigation, and all those aspects. So predominantly, this being the birthplace of Vikram Sarabhai, all of you may be aware that India space program originated from this particular place in Ahmedabad. And his vision was that we want to use space research and technology for the benefit of common man and society. So fulfilling that dream of Dr. Sarabhai, Earth observation in electro-optical domain, especially thermal infrared, which we were lacking since last many years. So I'm very glad that this mission will fulfill all the requirements which we have been looking for, and with the complementary payloads from our side being developed by our team led by Dr. Soumya Sarkar. And of course, we are looking forward to various new applications of this particular mission. And under the guidance of Dr. Rashmi Sharma and her team. So I wish all the best for this science workshop and hope that we'll have very good deliberations over these next 3-4 days. And once again, I welcome all the delegates for this important conference related to science and applications of this particular mission. So I wish all the best and thank you for coming here. Thanks.
Thank you, sir, for your brief overview. Now the moment has come to release the abstract companion of this workshop. I request all the dignitaries to kindly join the hands in releasing the companion. The companion reflects the depth of research and collaboration this workshop embodies. We hope it serves a valuable resource for all the participants. Thank you all. Now I invite Mr. S.S. Sarkar, Deputy Director, Sensor Development Area, to give opening remarks on Trishna evolution.
Respected dignitaries on the dais, esteemed participants, delegates from different countries, and my colleagues. First of all, Suprabhat, bonjour, a very good morning to all of you. Yesterday evening when Dr. Bimal told me that I have to give a bit of a history of how it evolved actually, so far as this mission is concerned, the Trishna mission. So since it was a bit of a history telling, so I'm bad at remembering dates. So I just am carrying this paper where we are having actually all the dates and all important dates actually how this concept or the mission evolved. Trishna, as our directors are told, and most of you would be aware as well, that Trishna is basically a Sanskrit word and it means thirst. It's like in Hindi that is called pyas. So it's basically the thirst for when you feel actually the need for water, kind of. So that is one connotation. There is another connotation which means basically yearning. That is a strong desire to achieve something. Your aspiration, strong aspiration. So maybe the second connotation actually fits in very nicely here, because this mission was conceived actually to meet with the stated objectives, and those were actually to study the ecosystem stress and water use, and also actually coastal and inland waters, and thereby actually add to the body of human knowledge, and also actually come out with practical applications for the global community as such, and of course scientific community. Trishna was conceived actually way back on 17th June 2014 to be precise, when a technical discussion was held between ISRO and CNES at Bangalore for a future mission in thermal infrared in order to address the objectives that which I just now mentioned. Then in 2015, actually, there was a cooperation agreement signed between ISRO and CNS, and that happened on 10th of April 2015. And that provided that broad framework actually because that mentioned about reinforced cooperation in space activities. And under the umbrella of this cooperation agreement is in 2016, an implementing arrangement was signed between ISRO and CNES in the august presence of the Honorable Prime Minister of India and then Honorable President of France. And that's what actually gave Trishna a formal base on a foundation. Then between April 2016 to May 2017, many scientific and technical discussions took place. And it was felt that there is a strong need for inclusion of a payload in visible and shortwave infrared, that is the VSphere payload, which our director also mentioned about. And preliminary instrument configuration studies were carried out. It was decided that the feasibility study for the development should be carried out in two phases. Phase 1, which had a duration of 6 months, leading to mission definition review, that is MDR, and phase 2 of duration of 2 years nearly, leading to preliminary requirements review. And accordingly, in November 2017, we had this mission definition review held in again Bangalore, and it was held with an objective to finalize scientific requirements, because science what drives the mission actually. So it was very important to firm up the scientific requirements and also to define a technically feasible and cost effective concept which meets the requirements of mission and system, data policy, payload concept, platform configuration, launch strategy, cost effectiveness, cost sharing, of course, work share and responsibility is between ISRO and CNES. Then from April 2018 to August 2019, there were various meetings that took place. There were science meetings, there were meetings on instruments for mission and also on spacecraft interface. So this was the time when a lot of discussions took place. And 28th September to 3rd of October 2019, we had this preliminary requirements review held, where the outcomes of mission definition review were discussed. They were reviewed and approved. And besides, it is in this actually PRR, that is preliminary requirements review, that besides the primary objectives of ecosystem stress, water use, and coastal and inland waters, there were certain secondary objectives that were also identified. And those secondary objectives were on urban fluxes, solid earth, which basically consisted of or consists of, I would say, volcanoes and earthquake, etc., and also cryosphere and atmosphere. Then in March 2020, the steering committee meeting took place, which basically again actually addressed or reviewed the PRR proceedings and approved those proceedings. And that's how actually the work started. And around the same time, that is in March 2020, the CNES program approval came. And then came COVID. So almost like for 1.5 years, all of us were affected, as you are aware. So once we were through from that difficult phase, then in 2021 to 22, the TIR payload and the system PDR took place from the CNES side. The ISRO approval came a bit time coming, but however, it finally came on January 2023 when the program approval was obtained by ISRO and the financial sanction followed. That is what was in April 2023. Then in June 2023, the implementation arrangement was again actually revised and it was signed between ISRO and CNES, and that basically provided the legal and I would say the procedural framework to proceed further with this mission. Accordingly, in November 2023, we had System Interfaces and Performance Validation Review, that is SIPVR1, which was held at URSC, and it addressed various aspects like system developmental plan, product definition, then data policy, then compliance of the system to the data policy and the science requirements, etc., etc. Then one important milestone for SAC, that is for us or for ISRO, happened on December 2023 when we had this vSphere payload BDR baseline design review held. In Q1 of this year, we had spacecraft and ground segment PDR completed. And in October 2024, just very recently, SIPVR2 was held at the CNES. So this is where actually, as on date, we stand in terms of development for this mission. And what is the road ahead? So if you look at what's the road ahead, it is basically in December 2024, we are going to have the vSphere payload PDR, and that would be followed by spacecraft and payload and ground segment CDR. So it's planned next year, that is in 2025. And in 2026, both the payloads TIR and SWIR, the payload deliveries are expected, leading to spacecraft integration and subsequently to launch. So this is in nutshell actually that like how the mission was evolved. So a bit of a history, and I sort of actually tried to traverse or navigate and bring you to the present status. So that is where we stand today. So I take this opportunity to welcome all of you, to all the delegates, and wish for a very fruitful, invigorating, and stimulating discussions. And certainly science is very important. So if there are any outstanding issues or there is anything which needs to be reinforced, I'm sure actually it will be addressed during this workshop. So once again, actually, I welcome all the delegates, all the participants, and wish you all the best. Thank you.
Thank you, sir, for your encouraging words. You have shown the complete evolution map of Trishna project, and I hope in near future we are going to meet the milestone defined for this project. Now, to provide an overview of this workshop, I request Mrs. Rashmi Sharma, Deputy Director, Earth and Planetary Science and Application Area, to address the gathering.
Thank you, and very good morning to all of you. Dignitaries on the dais, participants from various national and international institutions, from different space agencies, my own ISRO colleagues, online participants, a very warm welcome to all of you for this 3 days of International Science Workshop on High Resolution Thermal Earth Observation. So it gives me a great pleasure to tell you that in this 3 days of deliberations, we are going to have in-depth discussions on different facets of this thermal remote sensing, and of course with a special emphasis on Kenner's ISRO Trishna mission, where many of the applications would be synergized using the thermal data along with the visible and the SWIR data. And also we're going to focus on the LSTM and SBG missions as well. So I'm very pleased to inform you that there is a great amount of interest towards in the national and the international scientific community towards making use of this high resolution thermal data sets, and primarily for understanding the water stress for in the ecosystem domain. And I'm sure that when the data comes, it'll be able, it'll unravel many of the outstanding science issues and that are yet to be answered. It is said that well begun is half done, and we are very, very grateful to Professor V.K. Dadwal sir for gracing this occasion. And I'm sure with his vast experience in this domain under the ecosystem research area, his talk is going to inspire all of us, and it will set the context of this 3 days of scientific meeting. So thank you, sir, for accepting our invitation. The workshop technical sessions have been carved out very, very meticulously. Actually, it starts with the discussions on the global thermal missions that are going to be there in a couple of years, and which will be followed by the retrieval challenges that we face for this high resolution data sets, and challenges mostly for the terrestrial, coastal, cryospheric and hydrological parameters. We all know that calibration and validation is integral to any spaceborne missions, and that too for such a high resolution mission, it becomes even more critical to ensure the data quality. So plan for calibration, validation, ground instruments, campaign plans, etc. are very challenging, and I'm sure that the dedicated session in this meeting is going to deliberate upon all those aspects towards meaningful and high accurate data products and science products data sets. Another aspect which is very, very important is the development of the downstream applications, and addressing some of the key outstanding questions. And these are actually at the heart of any satellite missions that we launch. So towards this also, the session is dedicated to address water stress in ecosystem. And another important aspect which will be discussed is the urban and coastal heat extremes. So I'm sure that the outcome of these 3 days of deliberations on all these aspects, retrieval, calval, and science applications, will shape the future science and applications from the forthcoming thermal missions. And very, very importantly, it will also sensitize the users and researchers towards fully utilizing the data sets which are going to come from these missions. So with these words, I conclude, and I wish the workshop a great success. Thank you all.
Thank you, Dr. Rashmi Sharma, for providing a comprehensive overview of this workshop. Your insights underscore the significance of this collaborative initiative, and we are excited to dwell deeper into the session planned for 3 days. I now invite Mrs. Nagalakshmi Ma'am, Project Director Trishna, to share her thoughts and insight with us.
Good morning to all the dignitaries on the dais, representatives from across the globe for this workshop, and participants from India, and my dear colleagues from different centers of ISRO which are part of Trishna project. Greetings and very warm welcome to this workshop. It is with great enthusiasm and commitment we are presenting this workshop, celebrating the collective efforts towards the Trishna mission. Trishna represents a significant advancement in high-resolution thermal Earth observation, offering new insights into water resource management, urban heat studies, and ecosystem monitoring. This initiative, a collaboration between ISRO and CANES, highlights our shared commitment to sustainable solutions. Trishna, which is a joint collaborative project between ISRO and CANES, carrying state-of-art thermal infrared and visible shortwave infrared payloads, enables high-resolution thermal imaging of natural resources. The high-resolution data will be simultaneously processed at payload data centers to provide a consistent and systematic record of various biophysical variables along with the surface temperature profile to model surface energy balance. The payload data will enable monitoring of urban heat islands and fluxes along with evapotranspiration for estimating ecosystem stress and water use. Trishna is designed to acquire data globally using 4 thermal infrared bands around noon and midnight and 7 visible and shortwave infrared spectral bands with a spatial resolution of 60 meters, which stands as a unique resource for the global community. This science workshop will rightfully serve as an excellent platform, bringing together Indian and global science community and various user agencies, departments to understand and involve in the utilization of Trishna data and science products for the benefit of mankind. Besides the technical sessions, the organizing committee had also planned a tutorial which was a preamble to this workshop on modeling tools for thermal radiative transfer, surface energy balance, and evapotranspiration to further enhance the outreach and utility of this unique international science workshop to the participants. We are embarking on a journey to utilize Trishna's capabilities to tackle global environmental challenges with precision and impact. As we look forward to the insights and innovations this collaboration will bring, we are reminded of the vital role Earth observation plays in sustainable development. This workshop will serve as a catalyst for knowledge sharing, research, and progress in our mission to understand and protect our planet for future generations. We at India Trishna project team and our counterpart at CANES do understand the importance of this mission, and we know the commitment and the timelines we need to stick on so that we reach the goal of launch at the required timeline and the synergy which is required with the other follow-on missions. From configuration with respect to the science requirements and deciding on the equipments required, instruments required in order to meet this science mission, and configuring a satellite to carry these payloads to the space and addressing the requirements at the ground stations and the data products and the disseminations so that this data will be well received and well serve the scientific community with respect to the science objectives which was conceptualized initially. And at ISRO, we know that our objective is to realize and launch communication satellites, navigation satellites, remote sensing satellites, and space science missions to meet the requirements of the nation. ISRO has long association with CANES and has jointly developed various missions like SARAL and Megatropics. And we hope that this workshop fosters valuable collaboration and advancements in the field of Earth observation, and our collaboration with ISRO and CANIS will continue, and this workshop will aid towards that. Thank you so much.
Thank you, Madam, for providing insightful address. With the Trishna mission, we are eager to witness its remarkable impact on natural resources and management. We are delighted to have Mr. Philip Messengren, Trishna Program Manager from CANIS, among us. May I now request Mr. Messengren to address the gathering, please.
Thank you. Good morning. Dear directors, dear project managers and project members, dear principal investigators and scientists, dear conveners and dear colleagues, I'm very glad and it's an honor for me to represent CNES in this opening session as a program manager, it was said, program manager of Trishna at CNES. I have three principal messages, three principal things that I'd like to say this morning. The first one is concerning history of our project. The second one is concerning the programmatic strategy of our agencies, and then I would like to put the emphasis on the scientist involvement in the project. So concerning history, first, it's a fact that ISRO and CNES already have a long common history in their successful partnership. First with Megatropic, that was launched in 2011, and then SARAL, we all remember SARAL, launched in 2013, and these were two successes. Today, our two space agencies continue their collaboration with Trishna, that will be launched within the next 2 years by the end of 2026. Among all these years in the history of our partnership, for us, precisely concerning Trishna, there is a milestone which is important for CNES. It's the year 2019. In 2019, it's very important for Trishna at CNES and for ISRO as well, because it was the time of the preliminary requirement review, which was concluded successfully, thanks to the project managers and thanks to all the people that were involved. And the PRR, the preliminary requirement review was has oriented the project toward the phase A at CNES. An happy end after 5 years of work that was initiated at SAC, as mentioned by Philippe Gamet last Sunday. The history began here in this ISRO center. 2019 is also a very important year because at CNES in France we also had our own prospective seminar in October 2019, and during that seminar Trishna has been declared as a priority by all the French research institutes. Then in 2020, the few months later, in fact, the PRR steering board of CNES decided to switch toward the phase B. Then we all regret the COVID time period that we will try to forget. After the COVID, the IA, the implementing arrangement was signed by ISRO, which in its turn switched to the phase B. Since that time, two successful SCPVR occurred. It was mentioned previously, and I think it's an opportunity for me to thank and to pay tribute to all the ISRO and SNEC and CNES project members, and especially the project management, Miss Nagalashmi and Thierry Carlier, for their work and the way they manage this project, and all the people involved in it. The second part now is dealing, as I said initially, is dealing with the programmatic strategy and its consistency with all the international space agencies. In France, we have a very strong interaction with our colleague of the European Space Agency, and concerning the water cycle, we have some missions like SMOS, which is a mission of the Earth Explorer program, of the European Earth Explorer program. By the way, SMOS is going to be extended until 2028. It has been decided very, very recently. But of course, there is also the Copernicus program, and with the current Sentinel-1, 2, 3, and 6 that are very useful in the modeling, in the integrated modeling of the water cycle. This Copernicus Sentinel and the next generation, and among the next generation, there is of course LSTM. There is also S3 and JTOPO, and we all know that Trishna is the precursor of LSTM, and that, for example, SWOT. CNES NASA success is the precursor of S3 and JTOPO, which means that there is a strategy. Last but not least, there is NISA to be launched very soon, and we expect a lot from this the synergy of Trishna with NISA, with SWOT as well, to address the water budget issue. While Trishna will be combined with LSTM and SBG, and the gathering of their revisiting capacity will allow to address the evapotranspiration fluxes and their calculation. We all know that a strong effort has already been paid to optimize this multi-mission synergy in terms of products definition, in terms of FTBDs, in terms of orbit, and in terms of calibration validation. Third and last point, I said at the beginning, I would say some few words concerning the scientist involvement in that program, in that project. Maybe you don't know, but last February in France, we have held an inter-institute committee meeting, which has confirmed the involvement, of course, of the French Science Institute, all the French Science Institute and other public authorities. This meeting has shown many things. It has shown first a satisfying readiness of TBD levels. It has shown, and this is important, an increasing human and financial resources allocated to our laboratories. It's very important because without these resources, we cannot work. Additionally, we will know that we still have to go further into the research process, which is necessary. For example, on the thermal infrared and visible synergy, concerning directionality, concerning the assimilation of albedo and evapotranspiration calculation, but also on the Trishna data assimilation into agrometeorological models. It was stressed, we are at SAC, and applications are very important. And we all know that application need reliability, which makes the calibration validation exercise a very, very important issue. This is why, for example, it will require special efforts to coordinate our validation and our cross-validation at the level of our respective payload ground segments. Application, to finish, application development is very important at ISRO and at CNES. It was reminded to me by Dr. Bhattacharya a few days ago. And this is why we have at CNES a downstream program for the emergence of application, to facilitate the emergence of application. And in the domain of application, the last key word is timeliness. Timeliness is a crucial issue that will take advantage of the gathering of, by the way, of SBG, of LSTM, and of Trishna. To finish, technical and research team have already made impressive efforts in all this domain, in all the domains that I've mentioned, and I'm sure this workshop will be a very fruitful and useful meeting, and it will be very helpful to achieve our scientific and applicative objective. I'd like to express again my sincere gratitude to ISRO and SAC for hosting this meeting, with a special thanks to Dr. Bimal Bhattacharya for his tremendous involvement in the preparation of this event. And thank you to all of you. I'm sure we're going to have an excellent meeting during the 3 day. Thank you.
Thank you, sir, for highlighting the international collaboration and the vision behind the Trishna. Your perspective reinforces the importance of shared goal in advancing the space research. Thank you. I now request to all the dignitaries to kindly join the audience as we continue with the program. Please. keynote का है हाँ तो इनको ऑर्गेनाइजेशन लेकर बोलिएगा सबको एडवांस सर को जो है लेकर रखेंगे ठीक है बाद में
एडवांस हम यही रहेंगे ना एडवांस हम यही रहेंगे अब रहेंगे
उनको बोलो ना यही रहेंगे
यही रहेंगे ना सर
Next, we are going to have a keynote address by Dr. V.K. Dadwal. So before we proceed, it is my privilege to invite Dr. Rahul Nigam to introduce our esteemed guest of honor, Dr. V.K. Dadwal.
Very good morning to all. It is an absolute honor to welcome you all to this extraordinary gathering at International Science Workshop on High Resolution Thermal Earth Observation at Space Application Center, Ahmedabad, where brilliant minds converge to unveil the advances of thermal sensing. In the quest for knowledge, we are privileged to have with us luminary Dr. Vinay Kumar Dadwal. Professor Vinay Kumar Dadwal is currently the Indira Gandhi Chair, Professor for Environmental Sciences at National Institute of Advanced Studies, Bengaluru, in India. He has more than 38, 4 decades of research work and leadership at Indian Space Research Organization under different centers. He was a director of Indian Institute of Space Sciences and Technology, Trivandrum, from 2016 to 2021. He was director of National Remote Sensing Center, Hyderabad, from 2011 to 2016. He was a dean of Indian Institute of Remote Sensing, Dehradun, from 2004 to 2010. And concurrently, he held the post of director of UN Center for Space Science and Technology Education in the Asia Pacific during 2005 to 6 and 2009 to 10. He obtained his PhD in plant physiology from very prestigious institute termed as Indian Agricultural Institute, New Delhi, and joined Space Application Center, Ahmedabad, in 1983. In the Space Application Center, he headed the crop inventory and modeling division, and we are basically all the kids from that division. His research focuses on developing application of Earth observation data for vegetation, include agriculture and forests, and very importantly, land surface processes, hydrology, biogeochemical cycles of carbon, forest dynamics, and disaster management support. He has co-authored more than 325 peer-reviewed journal publications, which have more than 10,500 citations and co-guided more than 12 PhD students. He has been the chair of Subcommittee on Science and Technology of UN Committee of Peaceful Uses of Outer Space at Vienna in 2016. He was a president of Technical Commission 8 of International Society of Photogrammetry and Remote Sensing, ISPRS, 2012 to 2016, president of Indian Society of Remote Sensing, 2012 to 14, president of Indian National Cartography Association, 2013. He is a fellow of NAS, Indian Society of Remote Sensing, Dehradun, Indian Meteorological Society, New Delhi, International Academy of Astronautics, and received many awards and recognition. Because so many awards are listed, so I do not want to cut a list time. And I'm just shortcutting that I'm presently chairing 2 important technical groups, Technical Expert Committee for National Geospatial Program, Departments of Science and Technology, Government of India, and also chairing the Research Advisory Council for National Bureau of Soil Science and Land Use Planning, Nagpur. And now I request you all, please welcome him with a huge round of applause. Thank you. Over to Dr.
Good morning. Thank you, Rahul, for very kind words. Let me at the outset thank the organizers, Director SAC Nilesh Desai, and my friend Dr. Bimal Bhattacharya for inviting me to be present today on what I'm sure will be written in history as this Trishna Science Workshop at SAC. And there cannot be any better place than SAC to discuss the genesis of all new eras of remote sensing. I joined SAC in June 1983, and we are very lucky that we are now in a hall named after Professor Yashpal. Professor Yashpal had just shifted out to Vienna to head the Unispace 2 by the time we joined, and Professor Chitnis became the director. The keynote address can be many things, but I specifically took the advice of three my friends, Bimal, Mehul Pandya, and Dr. Samudraya, who headed the SIDA just before, I think even before Dr. Soumya Sarkar was there. So the emphasis is not to really give you everything that is done in India, but still focus on next. We could just start by looking at thermal sensors developed at SAC. Even before this campus was built, Dr. George Joseph, he joined the SAC before formally this campus, and they started working on an aircraft-based whisk boom sensor. And all the ones Mark 1, Mark 2, and HRMSs, they had a thermal channels. Then the INSAT 2A onwards, INSAT 1A was developed in USA by Ford Aerospace, but 2A onwards up to now, the last one is the INSAT 3DS, which was launched in February 2024. All of them had thermal bands. Unfortunately, thermal bands did not move down from geostationary to the Earth observation satellite. Instead, the thermal bands moved to the planetary exploration. So the group developed for Mars as well as Chandrayaan mission sensors which had thermal band. Now the thermal bands, they provide entirely complementary information of the vegetation, allowing us to compute energy balance, water balance, giving rise to hydrology studies, irrigation studies, and you can extend it even to the soil moisture and groundwater balance. Now this gets to be added by the other channel. So since the work on development of methodology is more towards the geostationary, I'll just take a couple of slides to discuss the single channel from Kalpana, the approach as well as the validation of the product. Second, the split window for INSAT 3D and 3D repeat. Next. And all this data is actually available at very frequent interval from 2017 and 15 onwards, 10 to 15 you can see. But unfortunately these resolutions are 4 and 8 kilometer. They do not lend themselves to the natural resources and other applications. So most of the Indian community had to depend on Landsat and Ester for all the work. So I'm sure the techniques are being developed and have been also, I think, done at SAC, which will allow emissivity and LST estimation, which may be very useful for the Trishna mission. Now, if we just take the size measurement of emissivity. So that work also is being done, but I'm sure much more would have to be done. Next. So if you just take thermal remote sensing and we search the literature, so roughly I think 450 plus papers are getting published by the Indian remote sensing community, and they cover all types of things: agriculture, crop studies, stress, drought estimation, ecosystem studies on vegetation functioning, soil moisture, evapotranspiration and hydrology, measuring of urban heat island, geoscience, exploration, geohazards, open fires, forest, not only the forest fire, but the underground fires which happen in the coal mines in the Singhbum area. It allows us to estimate various properties of those fires, and also in cryosphere. So the standard LST has been very routinely used uh, to talk of the snow melt, and in even the whether it is gross primary productivity or NPP, the LST comes as a water stress scalar and then gets assimilated into the normal functioning. I just will illustrate some of the work. So here, more I think the work done at SAC, and I have tried to avoid the work done by me. So the disclaimer is I do not endorse work, but all of them I think is important work. But it just talks of the type of areas and it talks of the challenges. Next. So one thing what has always I think been done is that whether you take Landsat or etc., very large effort is spent either in thermal sharpening or disaggregation. Obviously, I think many of the people feel that the current resolutions are not good enough. So what I'm hoping is when this Trishna comes and the type of resolution you have, there would be balance between the various bands, and then uh, because such disaggregation and sharpening, which predominantly have used vegetation as the covariate, haven't really led to very large scale operational applications. There have more been publications demonstrating accuracy assessment and algorithm development. So to move to the era, I think the resolution of the Krishna will be very important. More important is the MODIS has and LST has been used in most of the ecosystem models, as I explained to you, whether it is ET, whether it is the GPP and PP. I'm sure between a kilometer and 50-60 meter, there is a huge, 400 time difference. So the type of features which will be discriminated and analyzed will be entirely different, and there should be a totally a new era for applications. The other part is uh, this data has a power to really using the LST and NDVI to know something about the soil, the near surface or the active root zone part of the soil. The challenge has been that all these techniques basically are local area specific, can't be extrapolated very large, and you really have to work on the same data. And the for generally for soil moisture, 20% RMSE is very good. So we really are looking at what type of RMSE would be there in the Trishna era. But more importantly, when you move from such type of studies with this type of data to a high resolution, you would immediately find that the soil properties for digital soil mapping are not that high resolution available. So then the thermal remote sensing would have moved forward, and the other areas will then have to be developed, including the soil physical properties, soil organic matter, soil water holding, and permanent wilting point, right? That is something which I think will be there next. The other part is to really combine large number of approaches for soil moisture, uh, Landsat, the Sentinel-2, as well as the C-band SAR and other SAR. So such type of studies have been done to go up to even the field scale. Now, unless such studies are attached to a high repeat sensor, which allows you to make decisions of irrigation, then these studies do not really work in real time. So I think the 1 kilometer plus swath of Trishna will fill a very, very important gap to undertake this type of investigation, both from the retrieval of the surface soil moisture affecting the vegetation, as well as for the evapotranspiration. Next. Now, as far as the evapotranspiration is concerned, various approaches, energy balance, and other are available. I just thought I'll put this one, Dr. Bimal's work, where they are coupling the ET and the heat flux model to really explain the energy balance. I think a better energy closure will come, and the satellite driven approach will become more robust. And a challenge with this is to really calibrate the model and get for different vegetation type, you should have measurements which match this type of accuracy. So for that you require eddy covariance flux towers. Till 10-15 years ago, there were not many. So Dr. Bimal put the albedo towers. We had also put about half a dozen flux towers. Professor Shekhar Muddu also has flux towers, and I'm sure more are getting added. MOES has put 5. Forestry also, couple of them are there at FRI and the GB Pant Institute of Himalayan Development. More recently, under the World Bank Hydrology Project, NRSC has put about another dozen flux towers. So hopefully, I think the number of flux towers operating would now exceed around 35. So with this much, I think there would be, I think, more data to work on such model. Whether adequate or not still remains a question, because all vegetation categories are not, fully sampled. The hydrology project is concerned more about the irrigated areas. We were more concentrating on the forest in natural environment, and Ministry of Earth Sciences has concentrated, I think, more in the hilly region and coastal mangrove because of high carbon fixation. But this is an area I think we need to work. Next. Then there would be many novel applications. So in this one such noon night LST application, what is demonstrated, what you see in the circle, is to really look at the crop which have been affected by the root soil borne disease. The whole idea is we are looking at a region which doesn't have soil moisture stress as measured by thermal data, but actually it has canopy dryness. Generally, in most of the crop stress studies with visible NIR and SWIR region, you can detect the stress, but you cannot ascribe the cause. So what is being expected is, with this type of thermal complementary data, you would be able to really ascribe the cause of the stress, at least in some instances. That, I believe, would be another step forward for agricultural applications. Next. The one very large number of applications you see is the urban heat island. I just thought I will share with you the large number of institutions, whether it is IITs, universities, and so many other organizations which are on interest. Generally, the UHI has only concentrated on the variability, characterization, estimation of anthropogenic heat fluxes, right? And relating the UHI to LUNC and urban expansion. Hopefully, we haven't come down to city zoning, city planning, and the number of heat waves is increasing in India, and we really need to manage the urban planners need to really manage the local urban environment, not only for the uh, people, but also to cut down very huge AC load and other things which are happening. But when it will translate, when this type of studies will lead to uh, policies for urban zoning and urban management, I'm not sure, but I'm for the society and I think urban area, this would be a very, very important application. Next. To talk of the geology, I just took this example. Morning, I met Arindam. Yeah, so here the emissivity and LST separation allows us to differentiate the lithology. This one is from Dharwad Craton, Karnataka. And I'm sure most of the studies have either been in Rajasthan, Singhbhum, Dharwad, couple of uh, very, very extensively investigated areas. So there will be, I think, better delineation. There will be more classes. It may also aid in some type of exploration, mineral exploration also. Next. This is a very, very important area, but you don't really have clear-cut answers. There are many studies, especially from IITs, which have looked at the thermal anomalies before major earthquake. So some of the earthquake you get very good signatures prior to, but you would still can't predict where and when. Some of the studies which have, I think, different type of topography or climate, or the epicenter is very deep, there are no response also. But in the semi-arid and arid area, and even in the example of the the Himalaya Muzaffarabad, there have been publications which have detected thermal anomalies prior to the actual earthquake event. Next. Coming to cryosphere, you can use the LST and have snow melt prediction. For India, it is very important. You also, there are some more work is getting done. So in this case, the differentiation between supraglacial and periglacial debris because of the temperature to allow you to delineate the boundary by combining optical and thermal has been demonstrated. I think Dr. Bogana is there. He wants to do much more glacier and other work. But what I believe, although there are other issues, with better snow grain characterization and thermal, we should be looking very, very closely at avalanches. So that is another area, I think, with the Trishna era, and the type of swath and the repetitivity it has, there would be more avalanche-based studies, which for the geohazard as well as cryosphere, because in winter you lose regularly many lives because of the avalanches. It includes the tourists, includes the local citizens, and it also includes the security personnel. For all the three, it's very important. Next. I want to end by saying that Trishna represents a very significant enhancement of spaceborne thermal remote sensing, and it will definitely have emissivity and LST products, a spatial resolution to really delineate most of the features separately, and the 3-day sort of repeat coverage, and 8-day retracing the orbit will allow to track this with all thermal inertia applications of day night coverage. While the products will be there, I just looked at uh, wherever beyond the level 2, level 3, level 4 products are the one which the larger community uses, because it corrects for the gaps, it corrects for clouds and many other artifacts. So I'm sure the higher level of products would be developed for Trishna. So what exactly would be the challenge? So the challenge is a matching visible NIR sphere geophysical retrievals and the level 4 products to really do near real-time processes and fluxes of water, hydrology, irrigation, and some of the cases disaster. Through that, the remote sensing moves to a new era with thermal remote sensing. Up to now, what was demonstrated is actually brought into the practice for use of community. And I think the data model fusion, and with the availability of more ground observations on fluxes, we may be able to run much more the machine learning and other type of algorithms also, which hasn't seen in this particular case, but 2026 is not far off, right? And Megatropics took 10 years plus to deliver. Saral Altica also took some time, and I'm sure the NISR also we have been discussing. So if you really want a very, very big thing to be delivered, you need patience, and you need to continuously work and fill all the gap, which I'm sure all of you are more than capable of doing and delivering. So I really want to once again thank Director SAC, the organizers, Dr. Bimal, and uh, the Bimal, Mehul, and Samudraya, who shared some of this information, and have the wish you well in your new challenge of developing this new era of thermal remote sensing. Thank you very much.
Thank you, sir, for your enlightening keynote address. Your profound insight into the evolving application of thermal remote sensing in sustainable development have truly set the stage for meaningful discussions throughout the session. Your expertise in vision inspire us to think beyond the conventional boundaries and to explore the innovative solution for the challenges we face. We are deeply grateful for your invaluable contribution to the field and for sharing your wisdom with us today. Thank you, sir. Sir, please sit. Betty, please. It is now our honor to recognize and express our gratitude to Dr. V.K. Dadwal for his remarkable contribution in the field of remote sensing. I now request Dr. Bimal Bhattacharya to kindly join us on a stage to present the token of appreciation to Dr. V.K. Dadwal. Thank you, sir. As we draw to the close of this inaugural function, I now request Dr. Bimal Bhattacharya to deliver vote of thanks.
Good morning to all delegates and colleagues from other part of the world and Indian colleagues, ISRO colleagues. So I will not take much time between you and tea break. So first, it is a formal vote of thanks. I would like to place on record that as convener of Science Organizing Committee, I would like to express my deep gratitude to Chairman ISRO, Secretary DOS, Dr. S. Somnath, as well as CEO of CNES, Philip Baptiste, for giving go-ahead for this 3-day ISRO CNS Joint International Science Workshop on Thermal Earth Observation. And it was preceded by 2-day pre-workshop tutorial at Space Application Center ISRO in the backdrop of Trishna and similar other global follow-on missions. We are grateful to Director URSC M. Sankaran to provide basic guidance for organization of this science workshop and tutorial. We are extremely thankful to Director SAC Nilesh M. Desai to facilitate us to host such workshop and pre-workshop tutorial at SAC and for providing time-to-time guidance to organize this. We are grateful to all SMC members for providing their necessary support. The esteemed members of Scientific Advisory Committee from ISRO centers, IISc, CNES, European Space Agency, JPL NASA, USGS, USDA list provided timely inputs and feedbacks for preparing workshop objectives, flyers, structuring the agenda. We thank them all from core of the heart. We are indebted to Dr. V.K. Dadwal, Chair Professor NIAS, to agree to our invitation to deliver a very insightful keynote address in this event. We are delighted to have you here, sir, after a long time. We are extremely indebted to Chair LOC, Dr. I.M. Bohoguna, and Co-Chair Dr. Rashmi Sharma, and Member Secretary Dr. Rahul, and members of all local organizing committee for providing their necessary guidance for meticulous planning and execution of this science workshop. I would like to place on record that the hosting of this workshop would have not been possible without the hard work and dedicated efforts put in by conveners or co-conveners and all members of 10 subcommittees which have been constituted for registration, technical, then tutorial, website, then hall management, logistics, catering, finance, medical, etc. in a very well coordinated manner, and special thanks to admin, accounts and CISA personnel for their necessary help. We are very much thankful to Director URSC, Director IIRS and Director NRSC, Director ESTRAC and different other ISRO centers to extend their required support to facilitate the participation of scientists and engineers from their respective ISRO centers. We are indebted to Scientific Secretary, Director EDPO and also ISRO International Cooperation Office and DOS officials, MEA, to take up timely actions for arranging necessary clearances for this international event. There is an overwhelming response from CNES and its affiliated institutes, other institutes abroad, as well as from ISRO and Indian institutes, which led to the registration of more than 400 entries and submission of 134 abstracts. Heartfelt thanks to those who could join in person and also remote presenters, as well as global audience following this proceeding through internet webcasting on ISRO YouTube channel. We are extremely indebted to CNES, ISRO and Indian faculties from IIT, IISc for extending their expertise to Indian and Southeast Asian country students under CSSTP, young researchers and scientists through lectures and conducting lab sessions on various advanced topics related to thermal remote sensing. Special thanks to Dr. Shashmita, Yogesh and colleagues and SRTD officials and staff for well coordinated effort for this pre-workshop tutorial. Last but not the least, our special thanks to Project Director Trishna, AM Nagalakshmi Madam, to provide the fullest support to make this event happen. Thanks to all of you for coming here and hope you will enjoy fruitful discussion, interaction, scientific exchange during these 3 days. Thanks. Thanks to all.
Yeah, thank you all for your attention and wish you a very fruitful and engaging workshop ahead. Now, I request all to join for the refreshment which will be served in the basement. And with that, we'll have one group photo in front of auditorium. So request all to join for a group photo, please. And after 20 minutes, we'll be here for our technical session. Thank you.